Hello guys, and thanks for tuning in again. This is Brandon Clayton, the Algebra Guy, coming to you talking about equality and inequalities. How do you read them? How do you label them? How do you write them? This is some of the stuff that many of my students have struggled with, and I want to try to break it down in such a way to make it easy. So as you can see on our questions, I want to talk about what is equality and what symbol is used for it. That should be pretty straightforward. What is an inequality and how is it represented? And how does one read and label statements with inequality? So let's go ahead and get into it and with some examples. So first we're going to start off with the basic one, right? So we'll just start off with equals. So what is the symbol for equal sign? This is just this symbol here, right? So you can see that in something as simple as this, 3 equals 3. Or you may see it written a little bit more complicated, as in 2 plus 1 is equal to 1 plus 2, or 5 plus 6 is equal to 4 plus, what is that, 7. So this right here is just simply saying whatever's on the left side should be equal or balanced to whatever's on the right side. Now that's a basic idea, but just keep that in mind. That one of the ways I like to think of this later on is like a little balance. If you ever seen those balances, the old school balances, where you put something on each side, no matter how complicated it looks on either side, they both have to weigh the same. Why is that important? Because later on you're going to get into items that are not numerical, that are not whole numbers or integers. Instead of 5 plus 6 equals 4 plus 7, you may have something that looks like this. Or actually you will have something that looks like this. Let's say this is 2x plus 5, just to make it look interesting. Now this part right here can look confusing, but before you get confused or make it more complicated than it has to be, just remember they both are the same thing. They both have to weigh, if you will, the same thing. They both have to have the same value. This side over here, left side of the equal sign, has to be equal to the right side. They both have to stay balanced. So there's a number of things we can do to find out what the value of x is in this case, but that's another video. So I just want to make sure you understand what this equal sign means. It means that both sides are going to be the same value. As a matter of fact, when you know that, you can, once you find your x value, whatever that value is, you can plug it back in for x and solve each side. Let me change my color here. You can solve it for this side and solve it for this side, and they should equal. If they do not, it's not true. This would be a false statement, right? So if they were not true, like if you put that number in there and they came out different, that is a false statement. What do you mean a false statement? Because this is a statement. This is saying that x plus 3 is equal to 2x plus 5. So if you put a number in there and it makes them not true, that's not going to be true. Which leads me to my second point. So let me erase all of this. What is, I'll leave it there for now. No, I'll erase it. Change my mind. So what is an inequality? Well, if an equality means we have this equal sign, like we just showed, what is an inequality? An inequality is a symbol that we can use to show that there is not necessarily something that's equal. So what if you wanted to compare two numbers, 3 and 4? Well, these numbers are not equal. So you can't write that symbol there because that's a false statement. So how do you show that it's not equal? Well, one of the symbols we can use to show not equal simply is like this. That simply means 3 is not equal to 4. Simple enough. So that's pretty basic, but sometimes you might want to show a different relationship. You may want to simply say that 3 is less than 4, or 4 is greater than 3. See, they're still not equal, but now we're talking about an inequality that shows that one has a greater value than the other. So how do you do that? In this case, we'll write a symbol that looks like this. This symbol is showing that this, and a lot of teachers like to teach this with the mouth opening to the greater entity. So since 4 is bigger, we're going to open that to 4 and read that 3 is, since I kept talking about 4, let's read it like this. Let's say that 4 is greater than 3. But we can also say it a different way, can't we? So we read it from right to left, but you can also read these inequalities left to right, and they're still the same. So we read it from 4 is greater than 3. That's how we just read it. We read that 4 is greater than 3 with the mouth opening to the 4, but we can read it backwards. Let me get a different color to illustrate that. That 3 is, see, I'm looking this way and the mouth is closed. It's not opening towards the 3. So we're going to say 3 is less than 4. And you may be thinking, that's pretty simple. You know, of course 3 is less than 4 and 4 is greater than 3. But why is that important to look at it this way? Because what if I did it this way? Now you have to actually understand the symbols because you don't know the value. And some students get confused saying, we don't know what X is, so how can I say? Well, we can still talk about this relationship by simply saying that X is greater than Y. So if you read it this way, you see that X is greater than Y. But as I told you before, we can also read it backwards. I could have read it this way. I could have read it that way and said that Y is less than X. And both statements are true, right? Just like 3 was less than 4 and 4 is greater than 3, both are true. Both statements can be true. So just be familiar with what an equal sign and an inequality sign is and how you may use both of them. So we talked about an equal sign. We talked about an inequality that's like this where it's not equal. And we talked about less than and greater than signs. There are 2 more signs that we need to mention. And those signs look like this. So let's say here's one and here's the other. So now we put a line underneath. What do you think that line underneath is going to suggest? I'm hoping you said equal to. Because now not only are we saying it's less than or greater than, we're saying it's less than and or equal to. Less than and equal to something else. So let's give an example to drive that point home. I'm going to use hot pink. I'm going to make a little slash across here so we can kind of divide this page. So let's say that 10 is greater than or equal to 10. So the way I'm going to read that is 10 is greater than or equal to 10. So that's the key word there. Or it can be one or the other. And we can say, is 10 greater than 10? No. But is it equal to? Yes. So it qualified at least one of these conditions, greater than or equal to. And so this statement will be true. 10 is greater than or equal to 10. Now, what if we were using something that was not as easy to value, like a variable? 2x is greater than equal to y. How would we read that? Well, I just kind of said it, right? So 2x is greater than or equal to y. And if I'm going to read it backwards, how would you read it? You try it this time. I'm going to go this way. Well, now I'm going to say y is less than, good, or equal to 2x. So y is less than or equal to 2x as we look backwards. And again, both statements are true. So that's how you're going to write, read, and label equalities or inequalities. Now, not to overcomplicate it, you also will see inequalities written like this. I'm going to erase everything so we can show this. What if I had a value for x that was greater than 1 but less than 10? How would I show that? So I can say that I have some value that's greater than 1 and that same value is less than 10. Well, you can actually write that this way, or it's more commonly to put them together and looks like this. You'll write your smaller number on the left side, 1, and your greater number on the right side, 10. And you'll put your x in the middle, and now you'll read starting from the variable in the middle. And you'll know that x is what relationship to the 1? Well, x is greater than 1. So x is greater than 1. Notice that the mouth is opening towards the direction I'm reading. X is greater than 1. Now, what about 10? We said it was less than 10. So as I read to the other direction, to the right, I'm going to say x is less than 10. And notice that the mouth is closed toward the x as I read to the right. So this is reading x is greater than, it's kind of sloppy, sorry, greater than 1, and x is less than 10. So both of these conditions are true. So let's think about that actually. What value for x would satisfy this inequality? X value that's greater than 1 and less than 10? Well, that could be any number, right? Between 2 and let's say 9, or anything all the way up into 10, like 9.9, or anything greater than 1, like 1.2. So all those numbers in between, if I had a number line, so let's say I had a number line here from 1 to 10. The way I would write that to show it is I'll say it's not equal to, so I'll open a circle here, and it's not equal to 10, so there's an open circle here, and I can shade in this all numbers in between those two. So here's a just introduction to equalities and inequalities. It can go so much further as we talk about x being greater than 1, like if we were, or x is greater than 1. So if we had a number line and this is 1, let's say if x was greater than or equal to 1, then that would be a solid dot, and it'll go on forever in that direction because it could be all numbers greater than 1. So the discussion can continue on in a much deeper level, but I just want to give an introduction to equality and inequalities and how you can read and label those on your assignments. Thanks for tuning in. Again, I'm Brandon, the Algebra Guy, and I hope to see you next time.